Alright, so here's the deal. Remember when I said in decimal division we have to keep going until there's nothing left? Sometimes that goes horribly wrong. You've probably seen this, right? Think about what happens when we try to write the fraction 5/6 as a decimal. We're going to set that up as decimal division, right? With the 5 inside, the 6 outside. Of course, 6 doesn't go into 5 at all, so we'll add a 0 right away. So far, so good. 6 goes into 50. Let's see. 6 times 6 is 36. That's small. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. Okay, that's too big. It was 8. 6 times 8 is 48. Right, subtract. There's something left, right? So we need to add another 0. 6 goes into 20. Let's see. 6 times 5 was 30. That's way off. 6 times 4, 24. Getting closer. 6 times 3 is 18. Okay, so 6 goes into 20 3 times, with 2 left over. 6 goes into 20 3 times, with 2 left over. Do you see what's happening here? We're getting the same remainder again and again and again. Right, no matter how many times I write 3 here, I'm always going to have 2 left over. This pattern is going to keep going forever. Now, figuring out where the decimal point goes isn't that bad, right? We've got, we'll just ignore what's left over for a second. 8, 3, 3, 6, 5.000. We need 3 digits after the decimal point, right? But we need to somehow indicate that that 3 goes on forever. To indicate that a digit keeps repeating forever, we write a line over the digit or the digits that repeat. So we would say that 5/6 is equal to 0.83 repeating. Okay, 0.83 repeating. What's going on here is, well, some denominators just don't play nice with powers of 10. We can tell we have such a denominator because it has a prime factor that's not a 2 and not a 5. Any fraction we have, it is the case that the decimal will either stop or repeat. A decimal that eventually stops is called a terminating decimal. Right, so a terminating decimal eventually stops. We stop having a remainder when we do the long division. Right, these are the ones that we got from the decimal fractions. And we know how to do arithmetic to these guys. The decimals that repeat, a decimal that repeats a pattern of non-zero digits is called a repeating decimal. Technically, the terminating ones we could think have zeros going on forever, but that's boring. So a decimal that eventually repeats is a repeating decimal. Now, this is a fact. Every fraction can be written as a terminating or repeating decimal. And every terminating or repeating decimal can be written as a fraction. These ones we already know how to write as a fraction. These ones we're going to learn how to write as a fraction later. I'm not going to prove to you that this fact is true, but the basic idea is that there are only so many possible remainders. And remember that once we see a remainder again, our decimal is going to repeat.